your TA, and today I'm going to talk to you about the microwave method of moisture analysis. So the microwave method works on a principle of weight, much like the other ovens that we're looking at. However, the method that heat is produced in your sample to evaporate and take away the moisture to look at the differences in the weight is much different. The principle of the microwave is that it utilizes dielectric heating, meaning that it uses a non-ionizing alternating electric pulse that goes through the food, and because water is a dipole, meaning it has a partial negative and a partial positive charge on it, when that alternating field passes through the food, the dipoles tend to align with each other, which causes rapid movement of the water molecules and friction, which causes heat, and that heat within the food causes the water to evaporate. And once the water has evaporated and we get a steady reading of the food over the balance for a stable amount of time, then we know that all of the water has evaporated, and we can then measure the differences of the sample before and after the microwave field has gone through it and get a moisture analysis. So there are some really good advantages to utilizing the microwave technology. Because the electric fields are going through the sample and the heat is being generated within the water and the sample itself instead of the whole oven, we don't have to wait for the oven to come back down to temperature before removing and analyzing our sample. Also, because it's heated within the sample and it's an even field, if we have the good sample preparation with an even coating on our platform, we'll have really good even heating that will allow for very accurate moisture analysis. Additionally, this will take just a couple of minutes per sample, and it's very, very easy for inline use. So it's very rapid and we can use it inline. However, there are some disadvantages because this is not necessarily AOAC approved. And although you'll see here when we run samples in a second that it is calibrated for different types of samples, the data obtained from the microwave moisture analysis cannot be utilized for something like a nutrition label or any certificates of analysis, as this is not AOAC approved for final data. Another slight disadvantage, or something that you have to consider when utilizing your microwave technology for your moisture analysis, is that the calibrations are really based on a specific power and time of the food matrices that you're doing. So if it was a powder versus a cheese or a liquid, you would have to determine different microwave power as well as the time of analysis that needs to happen for your sample to be adequately dried and analyzed. Another small disadvantage of the microwave oven is that you can't really use it with foods that are high in carbohydrates because of how the heat is distributed and how it measures. You can have a high occurrence of the Maillard reaction, which will create or release more water than is there, and then you would overestimate your moisture. So really, this isn't a great option for foods that are really high in carbohydrates. So when we come over to the microwave, there are some options that we have, being a quick test, a create or edit method being what's calibrated and what we need, or load method. And since we have several calibrations or methods on this instrument, we can load a method that's already on here where we know the specific power that we need. So there's so many different ones. There's flour, tortilla chips, beer, and it comes even down to like a soy flour. We can get really specific. The first thing that we're going to be analyzing is the baby cereal, which is a flour like consistency, and because soy flour is very similar in composition to the baby cereal, we're going to be utilizing that method going forward. So I'm going to select that method and then I will hit ready. Then we can open it, and here on the inside, this platform right here is a scale, and it's a very sensitive scale. To start our analysis, we're going to take one of the analysis sheets and we're going to put it onto the scale. So this is the platform in which we will put our sample on for the analysis. And in order to get rid of the weight of the paper so we have a more accurate measurement of our sample, we're going to close the oven and tear out the paper. Now, if you can see on the screen, it's teared out the paper here. We can see the weight, and it wants us to fill the amount of sample between 2 and 3 grams on the scale. So I'm going to open it and now distribute my sample evenly on our paper platform so that it is between 2 and 3 grams on the scale. So now I have weighed out my sample so that it's between the 2 and 3 grams on the scale, and it's in a nice even layer on our platform. And you want it mainly in the center of the platform. None of it flies off of it, and you don't get an underestimation of your moisture content. So now we'll close it and hit start. So here on our microwave moisture analyzer, when we did the baby cereal, we saw that it came out to 1.77% moisture, and that prints out a little receipt in which we can see how long it took, the maximum temperature needed for the drying, and then the initial weight of our sample. And then it gives us our moisture percentage. So now I'm going to show you how we would analyze a cheese sample, and we have to change the method because cheese is not similar to soy flour. So we're going to look at our methods and then go over to cheese. And now we can do the same. We're going to tear out our sample platform just like we did before, and then add our cheese sample. So now I've weighed out my cheese sample, and we can see here for this method we can have between 2 and 4 grams. And again, you can see I have laid it out in kind of a circular even pattern. Also, you'll notice that from our block of cheese I've graded the sample, and this is important, like we had talked about in class, that we need to increase the surface area of our cheese, because if we just put a block of cheese on there or like a slice, there's a possibility that we could get moisture trapped within our sample that isn't expelled within the analysis, and then we would overestimate or underestimate our moisture content. As our sample is running, we can see that the moisture percentage is going down, as well as the weight percent, or the weight in grams right here is going down, and that's our moisture being lifted, or the water evaporating from our sample that is giving us the moisture content. So again, for our cheese sample, we have the drying time, which was much longer than the flour, mainly because there's more moisture, as we can see, and then the temperature is much different because we have a different method, and then we again have our different initial, and we can see from the soy flour or our baby cereal being 1.77% moisture that the cheese was 34.17% moisture. And additionally, here, when we take our sample out, we can see that it has been heated and the moisture is left. So next, even though this is not one of our samples that we're doing in class, I have a milk coffee beverage that I wanted to show you. We can even run liquids on this, so you have a wide variety of foods that you can use on the microwave oven. So what I'm going to do for this is put it on our milk method, and then I will again take the same platform and put it onto our scale and tear it out. And now, instead of weighing to get between our 2 and 4 grams, I am going to use a transfer pipette to spread my 2 to 4 grams in an even layer, almost circular, so I can ensure to get a nice even distribution on my sample pad. And now we would measure it just as normal. So now that we've run the milk beverage, we can see that it was 97.43% moisture. And again, we can compare from our baby cereal and our cheese and then the milk sample, the different drying times, temperatures, and then weights required, as well as we can see the differences in moisture between the 3 samples. So I think from this demonstration, what we learned today is that the microwave can be utilized on a wide variety of samples, and it has a lot of advantages as being accurate, and it's really fast for rapid inline processing, but it also has disadvantages because we can't utilize this information for a nutrition label or anything with final data, but it is good as an indicator along the way for processing.
Hey everyone, I'm Brigitta, one of your TAs, and today I'm gonna show you how to weigh your sample and prep your sample for forced draft. So first, when you come into the lab as a group, you will find your aluminum pans in the desiccator and your sample. And each group will do 3 replications of your food sample. So first thing that you want to do before weighing the sample is take a look at your balance and record the number of your balance. You want to do this because throughout your experiment, you want to use the same balance to avoid any fluctuation. So if you use different balance, there might be variability between the balance, and we don't want that. So first, for forced draft, you want to take out your pan with a tongue. So open the desiccator and take 1 pan. So each pan has been pre-dried and pre-labeled, so make sure that you take the right pan. So for forced draft, the label would be C1, C2, and C3. And so today we're doing almond sample, and so the label would be AC1, which means almond C1. And so you can tear your analytical balance and then put your empty pan. And for forced draft oven, you want to use glass wool. So we prepared glass wool for you also in the desiccator. And what you want to do is to take your forceps and then take out 1 layer of glass wool. Like so, and then put it on top of your aluminum pan. And you can close your analytical balance and record the weight of your empty pan and your glass wool in your notebook. Once you do that, you can open your analytical balance, take your glass wool, and weigh your sample. And you want to weigh 2 grams of your sample. So once you weigh 2 grams of your sample, you have to spread it into a thin layer on your pan. And we want to spread the sample into a thin layer to make sure that there will be even heating throughout the drying process. So once you do that, record the sample weight in your notebook. And then after that, you can put back your glass wool on top of your food sample. Okay. And then record the weight of your pan, of your sample, and of your glass wool in your notebook. We are using glass wool for the forced draft because forced draft has air convection and you don't want your powdered sample to fly away. So after doing this, you can take your sample out and put it back in your desiccator, like so, and then you will repeat all of the steps for your second and your third replication. And after you have weighed all of your samples, you will go down to lab 95 and Pam will show you how to put your samples in the force rack. Hi everyone, I'm Brigida, one of your TAs, and today I will be showing you how to prep your sample and how to use the vacuum oven to determine your moisture content of your food sample. So we use vacuum oven because it operates under lower pressure. The lower pressure will reduce the boiling point of the water, and therefore the water will evaporate at a lower temperature, and that way we can avoid decomposition of food component in your sample. And this method is fairly simple. All you need is your aluminum pans, your samples, tongue, analytical balance, spatula, and the vacuum oven. So for the two groups that are doing processed cheese and cheddar cheese, you want to grate your cheese sample first into small particle size before weighing them on your aluminum pans. By grating the cheese, we will ensure that your samples will be heated properly and uniformly throughout the heating process. Okay, so when you come into the lab, your group will have your own bench right here, and on your bench you will find your aluminum pans and the desiccator. We keep the aluminum pans in the desiccator to prevent any moisture, addition of moisture from the atmosphere. So that way we will not introduce any moisture that will create our data to be inaccurate. And so today I'm gonna show you how to prep your samples, and I will be using ground almond samples. So first, what you want to do is take off the lid of the desiccator and grab one of your pan with a tongue. So one important thing to remember is that each pan will be labeled, is already labeled with according to the sample and according to the method of drying. For vacuum oven, it will be labeled V1, V2, and V3. V stands for vacuum oven, and 1, 2, 3 is the number of your replicates. So once you took out your aluminum pans, you can weigh the weight of the empty pan. And you want to record the weight in your notebook. And once you've done that, you can tear your pan. You can tear the analytical balance. And then the next thing you want to do is to measure 2 grams of your sample. Okay, and then make sure that you spread your sample into thin layer. Okay, you want your sample to be spread into thin layer to ensure even heating of the food sample. And then, of course, you want to record the weight of your sample. And then once you do that, you can pick up your sample, put it in the desiccator, and repeat the steps for your second and your third replicates. Cool. And now once you weigh out all of your 3 replicates, you can bring this desiccator with your tongue to the vacuum muffin.